Hi kids, in this video we'll continue with laws of motion और हम लोग inertia डिस्कस करेंगे। इसके पहले वीडियो में हम लोगों ने न्यूटन्स फर्स्ट लॉ ऑफ मोशन को डिस्कस किया था। हम लोगों ने देखा था वहां से हमें दो चीज मिलता है, एक तो डेफिनेशन ऑफ इनर्शिया और एक तो डेफिनेशन ऑफ फोर्स। और इनर्शिया क्या था? वी हैव डन इट इन द प्रीवियस वीडियो। It's an inherent property by virtue of which a body tends to retain its state of rest or motion। हम लोगों ने प्रीवियस वीडियो में ये किया था, इसको एक्सप्लेन किया था। यानी कि अगर एक बॉडी अगर रेस्ट में है तो वो रेस्ट ही में रहना चाहता है। सपोज ये एक बॉडी है, इट इज इन रेस्ट, सपोज V0 है, बॉडी क्या है? रेस्ट में। तो ये रेस्ट ही में रहना चाहता है। और ये कब तक रेस्ट में रहेगा? जब तक कि कोई अनबैलेंस्ड फोर्स doesn't act on it। जैसे ही कोई अनबैलेंस्ड फोर्स इसमें एक्ट करेगा तो इसका स्टेट जो कि रेस्ट था वो चेंज हो जाएगा। देखिए, ध्यान से देखिए। फर्स्ट ऑफ ऑल द बॉडी इज एट रेस्ट, तो यहां से एक वेट इसका डाउनवर्ड नीचे एक्ट करेगा, इसी के बराबर एक नॉर्मल रिएक्शन फोर्स वर्टिकली अपवर्ड रहेगा। नाउ व्हाट हैपेंस? सी, दीज आर बैलेंस्ड फोर्सेस। What are balanced forces? Balanced forces. When we know force is a vector quantity. When the sum of forces on a body, sum of forces means the net force acting on a body. When the sum of forces on a body, net force is 0, then we say balanced forces. Normal reaction force and weight of the body, the numerical value is same, they are opposite in direction, so they will cancel each other. So the net force on this body is 0, this body is not moving. Unbalanced force क्या होता है? And when a body is experience balanced forces, the state of the body does not changes. If it's in rest, it will remain in rest. If it's in motion, suppose your body move कर रहा है, it is in motion, there is a velocity with which the body is moving, वो velocity same रहेगा जब तक कि इस पे balanced force act कर रहा है। Now, as soon as an unbalanced force acts on the body, तो unbalanced force क्या होता है? Unbalanced force, which means the sum of forces or the net force acting on the body is not equal to 0. Then what happens? Then if a body experiences an unbalanced force, then the state of the body, this unbalanced force changes the state of the body. If it's at rest, suppose I apply an unbalanced force F over here, so this body starts to move, changes the state. If the body is already moving with a constant speed, with the same speed in the same direction, then what happens if you apply an unbalanced force? Two things can happen: change in direction or change in speed. In both the cases, the state of motion is changed. So that was inertia. The body resists any change unless an unbalanced force acts on a body. Now we'll see how inertia and mass are interrelated to each other. mass and inertia. Now I can write mass is the measure of inertia. इसका क्या मतलब होता है? Just look carefully. Inertia and mass are directly proportional to each other. Inertia is directly proportional to mass, which means the tendency to resist a change will be more if the mass of the body is more. Okay, if the body is at rest, suppose we take two bodies, suppose this is your body A, this is your B, the masses are different. This is suppose 10 kg, suppose this is 20 kg. They are both at rest. Now, if you want to move or set the body in motion, suppose this is F1 unbalanced force and you applied F2 unbalanced force on the body. We'll see that more force is required in case of body B because the mass is more. F2 will be more than F1 because the property to resist change will be more in this body due to the mass of the body. The mass over here is more, so the inertia, the tendency to resist the change will be more as compared to this body. So inertia is directly proportional to mass. More the mass of the body, more will be inertia, the property of inertia. The tendency to resist any change will be more in that body. We must have seen, suppose you have a loaded truck, we have unloaded truck. They both are at rest. Then you need some unbalanced force to set both the truck in motion. Suppose over here, rest to motion, force applied is F1. Over here, rest to motion, the force applied is F2. We'll see that F1 will be more than F2, loaded truck. Even if suppose they both are moving with the same velocity. Suppose they both are moving with the same velocity and we want to stop. Then again in this case, with the loaded truck, the force required to stop, suppose motion to rest. Motion to rest if you want to change. They both are moving with the same velocity. Then what happens? Suppose this is F3, F4. Again F3 will be greater than F4. Mass is the measure of inertia. The more the mass of the body, the more will be its property of inertia. The tendency to resist the change will be more. It depends on the mass of the body. Now inertia is again divided into two types. Inertia can be divided into two types. Over here see, rest to motion, motion to rest. So we have inertia of rest and we have inertia of motion. What is inertia of rest and what is inertia of motion? Let us study them one by one. Now inertia is divided into two parts. We have inertia of rest, inertia of rest, inertia of motion. What is inertia of rest? If a body is at rest, it remains in the same state of rest, unless an external, you can say unbalanced force acts on it. It will remain in that state of rest. That is your inertia of rest. What is inertia of motion? If a body is in motion, it remains in the state of motion, of course, in the same direction in a straight line, with the same speed, unless an external unbalanced force acts on it. That is your inertia of motion. We have a lot of daily life experiences where these two we can notice. Let us look. I've got this Concise Physics book, They've given a lot of examples, kinds of inertia and its example as illustration of first law. The first one, inertia of rest. They've given the example. When a train suddenly starts moving forward, if the train is moving forward, the passenger standing in the compartment tends to fall backward. We must have experienced that. Very easy to explain. Look over here. What happened when the train or the bus, wherever you're standing, if you're standing, suppose, then what happened? As soon as the train or the bus sets in motion, the lower part of your body shares that state of motion, but the upper part of the body is still in the state of rest, which wants to be in rest. So what happened? Suddenly the lower part moves, but the upper part is still at rest or want to be at rest. So what happened? You tend to fall backward. That is the reason. Clear? Yeah. Second one, see, when a hanging carpet is beaten with a stick, the dust particles start falling out of it. Very easy. Suppose you have a carpet which have a lot of dust particle. Then you hold it vertically, and when you beat it with the stick, what happens? As soon as the stick, gets in contact with the carpet moves back. Motion, from state of rest, we are changing to motion. So it moves back. But the dust particle which has settled on the carpet due to its state of rest wants to be at rest. So it remains in that position. And due to the gravity, it falls down. Clear? Now, next. On shaking or giving jerk to the branches of a tree, the fruits fall down. Again, very easy. See, the fruits are attached to the branches by a very, you can say, thin twig, And when you give a jerk or when you shake the tree, what happens? The tree state is changed from the state of rest. Now it's moving. Motion is created, due to the external force, but the fruit still wants to be at rest. What happens? See, suppose this is a branch and over here the fruit is attached. Mango is my favorite fruit, that's why. Now what happened? This branch starts to move. Even this portion over here starts to move, but this fruit wants to be at rest only due to inertia of rest. So a tension is built up at this position, and this is a weak, point of contact. And due to the pull of gravity, what happens? This fruit falls down. Okay. Then they have told, on striking the coin at the bottom of a pile of carom coins, those who play carom will be familiar with this. With a striker, the lowest coin along moves away while the rest of the pile remains intact. Let's see if you have played this. With the striker, you apply force, you hit the lowermost, coin. What happened? You impart a force to this lowermost coin. It was at state of rest. So what happened? It starts to move. It moves. But these pile of coins, they are at rest and they want to be in rest. So as soon as this moves from here, this pile falls down due to the gravity pull. Due to the pull of gravity, this falls down, this comes down, isn't it? Now, when a smooth card placed over the mouth of a tumbler is flicked sharply in the horizontal direction, the card flies away, but the coin kept over the card falls into the tumbler. The logic remains the same. What happens when you're flicking the card? You're imparting force. You're providing force. From rest, state of rest is changed to state of motion. But the coin which is kept over it does not share that motion. It wants to be in the rest. So what happens? It falls in the glass which is kept below that. Clear? Due to the pull of gravity, of course. Now there is one more. When a corridor train suddenly starts, the sliding doors of some compartments may open. That's quite obvious. See, the sliding doors are attached to the frame of the door, and the frame of the door is attached to the floor of the train. So when this train starts to move, the frame, the sliding doors frame, that also starts to move, but the door, due to its inertia of rest, wants to be at rest. So what happens? The door slides in the direction opposite to the direction of motion of the train, and few of the sliding doors in the compartment may open. Yeah. Clear? So these were few examples which they have discussed in relation to inertia of rest, which we see in a real life, Now, inertia of motion, again we have discussed. If a body is in motion, it remains in the state of motion in the same direction, in the straight line, with the same speed, unless an external unbalanced force acts on it. They give given few examples. First one, a cyclist riding along a level road does not come to rest immediately after he stops paddling, because the cycle was in a state of motion. So it wants to be in motion. So the motion continues, but there is a force of friction, opposing force. So slowly what happens? The cycle comes to rest. It will come to rest due to the friction between the tire and the road. We have discussed frictional force. Okay. Second, when a passenger jumps out of the moving train, he falls down. See, if the train or the bus is moving and you suddenly jump and try to stand, okay, what happens? Your entire body was in motion. So when you jump, the lower part of the body comes to rest suddenly, but the upper part of the body wants to be in motion in the same direction in which the bus or the train is moving. So you fall in the same direction in which the bus is moving. So it's always advisable, first of all, to don't jump from a moving train or a bus. That's totally wrong. If somebody jumps, please don't jump. If somebody jumps, then after jumping, you need to run a little in the same direction as the direction of the bus or the train to avoid falling. Am I clear? Now, third one they have given, when a running car suddenly stops, the passenger tends to lean forward. So what happened? Suppose the car is in motion, the bus or the train is in motion, and when it suddenly stops, the lower part of your body comes to rest, but the upper part is still in motion, wants to be in motion rather, still in motion, no? Wants to be in motion due to the property of inertia of motion. So what happened? You lean forward. Am I clear or not? Now, an athlete, number 4, an athlete often runs before taking a long jump. The reason is very simple. While running, what happens? The entire body is in a state of motion. So it's very easy to take jump. You can cover a long distance, long jump. But you can't stand and jump. If you stand and jump, you can. But the distance covered, the jump will not be so effective. So what happened? You need to run. You need to run before taking a long jump. Clear? One more they have discussed, a ball thrown vertically upward by a person in a moving train comes back to his hand. Now, when you're moving in a train, see, you need to remember the body, your body is in a state of motion. The air inside the compartment is also in the state of motion. The ball which you throw, everything inside the compartment is in a state of motion. So when you throw the ball, it went vertically up, but it is in a state of motion also due to inertia of motion. So what happens? It also moves and it falls in your back to your hand. Clear? So I think in this video, keep it till here. The rest of the part we'll discuss in the next video. That's quite interesting. We'll discuss about Newton's second law of momentum. That's very important. Okay. If you like this video, do subscribe the channel.